Hi guys, so we're gonna redo this quiz. I'll select different problems, but they'll be, different numbers and stuff, but they'll be very similar. So we're gonna use L'Hopital's rule to evaluate the limits, and there'll be a problem on the back. So let me get this thing out. Okay, so I will keep referring to this L'Hopital's rule format, and I'm also going to be referring to this because the biggest problem we had on the quiz was with our notation. So if there is a limit outside, then you need x's inside, and also vice versa. That's what that two-way arrow means. So if you've got x's inside, then you need the limit outside. On the other hand, if you don't have any x's on the inside, like after you direct substitute, so I'll say after direct sub, you will have no more limit outside because you won't have any x's inside because you will have plugged in for the x's. So hopefully this will help. Yeah, we're just a little rusty on the notation, which is very normal. So the first step is to direct substitute. So equals 5 times infinity, e to the infinity. Notice I have no limit outside because there's no x's inside. And then 5 times infinity is infinity, e to the infinity is infinity. This is one of the forms that you want to look for. So I say therefore, by L'Hopital's rule, okay, so I've completed these steps. I'm on this step right now. So the above limit is going to be equal to this. And I'll just say therefore by L'Hopital's rule equals the limit as x approaches infinity. Now at this point, you take the derivative of the top over the derivative of the bottom. Derivative of 5x is 5. Derivative of e to the x is e to the x. I have x's inside, so I need the limit outside. All right, no x's inside, I would need no limit outside, but I've got x's, so I need that limit. And then you direct substitute again. 5 over e to the infinity. No more x's, no more limit. So this is 5 over infinity. And guys, a lot of people got this part wrong. That's actually 0. All right, because 5, do you think 5 over 100, 5 over 1,000, 5 over a million, 5 over a billion? That just keeps, this whole fraction keeps getting smaller as the denominator gets bigger. So it's approaching 0. Okay, so this would be the answer. All right, that's number 1. Number 2, first you direct substitute. So e to the 1 minus 1 minus 1 over 1 minus 1. So no more x's inside, so I drop the limit outside. E to the 0 minus 1 over 0. E to the 0 is 1. All right, so I've got 0 over 0. And you didn't need to show every step I showed. Just show the direct sub, and then 0 over 0 would be fine. So now I can use L'Hopital's rule. So therefore, by LHR, this is equal to the limit as x approaches 1. The derivative of the bottom is just 1. The derivative of the top, I've got to use chain rule because I've got x minus 1 inside, e to the blank outside. The derivative of x minus 1 is 1 times derivative of e to the blank is e to the blank. X minus 1 goes back in. And then the derivative of 1 is just 0. So this is e to the x minus 1. Now I can direct substitute again. E to the 1 minus 1 over 1. That's e to the 0, which is 1. All right, so here I dropped the limit because I had no more x's inside. Okay, now guys, just one more. All right, so first I direct substitute. 2 times 2 squared minus 4 times 2 f of 2 times 2 plus 2. So this is 8 minus 8. That's f of 6. So I find 6 for the x value, this is the f column, so it's -2 for the y value. So -2 plus 2. 0, oh, you couldn't even see. 0 over 0. Therefore, by L'Hopital's rule, this is equal to the limit as x approaches 2. Derivative of the top is 4x minus 4. Derivative of the bottom, for this term here, the derivative is 0, but for this term, I need a chain rule. So the inside would be 3x outside f of blank. 3 f prime of 3x. So 3f prime 3x, right? Now at this point, I direct substitute. That was just like an aside. So at this point, I direct substitute. 2 goes in for the x, so that's 6. Okay, no more x's inside, so no limit outside. So this is 8 minus 4 all over 3 times f prime. This is the f prime column. F prime of 6 is -3. So this is 4 over -9. Okay.